Hello, calculus fans. So the real question for a calculus class is what happens when the force is not constant? We want to be able to calculate work done by a non-constant force. So the force may be changing. So we'll suppose that an object moves along the x-axis in the positive direction from x equals a to x equals b. And that there's a force that's acting on this object. That force is f of x, and we'll just say that that's a continuous function. Now we're going to play our usual game. We divide the interval from a to b into n equal-sized subintervals with partition points. The partition points are going to be x0, x1, all the way to xn. Of course, the width of each subinterval is delta x equals b minus a over n. And in each subinterval, x sub k minus 1 up to x sub k, we choose a sample point, xk star, and then the force at each xk star is f of xk star. Now if n, the number of subintervals we pick, is large, then delta x, the width of each subinterval, is small. And since the function is continuous, the values of f, they don't change very much over the interval from xk minus 1 to xk. The important thing is that the force is pretty close to constant on that interval. So we can calculate the work done in moving the object from xk minus 1 to xk is pretty close to f of xk star times delta x. This is a force times a distance. So we have to think of delta x as being a distance that we're moving the object. Now we can approximate the total work done. It's the sum of all the work done on each little subinterval, and that, of course, is the sum, as k goes from 1 to n, of f of xk star delta x. So we add up the total amounts of work. So on each subinterval, we can approximate it pretty closely by just taking force times distance. Now, as the usual sort of thing goes, this approximation will get better as n gets larger. And based on that, we're going to define the work done in moving the object from x equals a to x equals b as the limit of this quantity as n goes to infinity. That gives us a limit of a Riemann sum, and that, of course, leads us to an integral. So the work is going to be defined to be the limit of this Riemann sum, and we know that that's equal to the integral from a to b of f of x dx. So we're taking this integral right here to be the definition of work done by a variable force. If the force is constant, it's easy. We just take that force multiplied by the distance. This integral is what we have to use when the force is variable. Okay, that's all for now.